This is an odd one. Well, actually, 6 is an even number, but bad joke. Anyway, let's just do it. This one factors as well, but I hope you realize what's going to happen, so you might could just save yourself the trouble and not even factor it, but nothing's going to cancel, clearly, because there's nothing in the numerator that's too fantastic. It's just a 9, so nothing's going to cancel. I know you're like, oh, I can make that 3 and a 3, and yeah, whatever, but no factors are going to cancel. So let's just go ahead and say that this graph has no holes in it. There are no holes in my graph. There's nowhere where we have 0 over 0, okay? But we do have an x-intercept, possibly. We do have a y-intercept, possibly. We do have a horizontal asymptote, possibly, and a vertical, possibly. You don't have to have all of them. Okay, so x-intercept is where y equals 0, so 0 equals, skip it and go to here, so 9 over x minus 3. I hope by this point you realize it's just the numerator that I need. So x equals 9, 0 equals 9. That is a false statement, which means that's false as well, which means that if I'm going back to the very beginning of my notes, then I need to say that this is number 2, by the way. Mark that out. You could or not. It's up to you. Either way, it's a false statement. So there are no x-intercepts. But we will talk about y-intercepts a little bit, and that's going to be where I plug in 0 for x. So y equals, you could use the original, you could use this one. I'm going to actually use this one, even though it might seem like a slight waste of time. It's just kind of fun. So 0 minus 3, 0 plus 3, and that gives me 9 over negative 9, which is negative 1. So my y-intercept is at negative 1. If you want to get technical and say, oh, that's really a coordinate, I hear you. It's 0, negative 1. So let's put that dot down. 0, negative 1. All right. Horizontal asymptote is where this graph levels off horizontally. If it does. Some of them don't, by the way. There are several that do not, but not on these notes, not right now. Horizontal asymptote is where it levels off horizontally, and I know up to this point I've said, oh, this is like 1 over 1. Well, this is like, I'm going to go back to this one. This is like 0 over 1. Okay, so here's kind of an awkward way of looking at it. This is x squared. This is not x squared. I could say, and I'm going to write this lightly in pencil, I have 0x squareds here, and then plus 9, plus whatever else. And so I have 0 divided by 1, and that's why this one is going to be 0. And if that didn't make sense, do not panic. I put a 1. I should have put a 0. My fault. Okay, so here's the actual graph of it. And you can see that it levels off. You can see the ceiling fan again. But you can see that it levels off right here. Now, you might could say, well, what about that down there? Well, that's just an x-intercept. But when I'm looking at where it, y-intercept, but where it really levels off, like up here and over here, then that is at y equals 0. That's basically the x-axis. And so then I also have a vertical asymptote, or 2, and that is where my denominator equals 0. So it's where x minus 3 and x plus 3 multiplied together equals 0. So you could say this is one of them, so 3, and you could say this is another one, so negative 3. And you actually have 2 vertical asymptotes here. You can have 2. You never can have 2 horizontal asymptotes. Well, not right now anyway. Okay, so we have a horizontal asymptote here, so I'm going to draw that, well, there, which was slightly pointless. And I have a vertical asymptote here at negative 3, and a vertical asymptote at positive 3. And I can see the graph of this, and it looks like this, kind of. It's not perfect, but it's somewhat like this. And it comes down right there. And never crosses the asymptotes. Never curls away from them either, like I had accidentally drawn that.